All right, guys, Uncle Latimer here. This is trial run number 1 of our solutions video. Real quick, evidence, it's me. Yeah, it's me. Love you guys. All right, so these are this is gonna be the solutions to assignment number 1 for Algebra 2 Honors, whether you have Miss Crocker, Miss Jennings, Miss Williams, or you're stuck with Uncle Latimer. All right, so the point that I tried to make with my students today is that when we are looking at the equation, don't just blindly plug in numbers. Pick numbers that make sense given the equation. So when I look here and I see that this is 2y minus x equals negative 2. My first thought is, man, if I just plug in 0 for x, that's not a problem. The leading coefficient is 2. Which means if I can, I'd like to keep this number even, so when I have to divide by 2, I get an integer as opposed to a fraction. Now, let me be clear. I'm not scared of fractions, okay? I'm not scared of some little wussy fraction. But it's hard to plot a fraction in a grid like this. So unless I have a calculator or a computer to plot the graph, I would prefer to keep my answer as integers. And so I'd like to use 0, 2, and 4 for x, okay? So 2y minus 0 equals negative 2. 2y equals negative 2, so y equals negative 1. I should have been more organized here. So now I'm going to plug in 2 for x. 2y minus 2 equals negative 2. Add 2 to both sides, and 2y is equal to 0. Divide both sides by 2, and y is also equal to 0, which means we have our second ordered pair, 2, 0. Now, I'm not sure about Miss Jennings and Miss Williams and Miss Crocker, but guys, I absolutely hate the word cancel. Cancel to me is a baby middle school term that means you don't really understand the math behind it. Negative 2 plus 2 is 0. That's not canceling. 2y plus 0 is 2y. 2y divided by 2 is 1. 1 times y is y. That's not canceling. We do not say cancel. We add 2 such that 2y is now being added by 0, and we divide by 2 so that y is now being multiplied times 1. But we do not use the word cancel. Okay, so for our last one, I'll come over here. We're plugging in x equals 4. 2y minus 4 equals negative 2. Add 4 to both sides. So 2y is equal to 2, which tells me that y is equal to 1 when x is equal to 4. Now, I told my students I love for them to take this table of values and turn it into an ordered pair. It's not a huge deal, but it's a nice, friendly little reminder. Additionally, 0, negative 1. The reason that we plot at least 3 points is very simple. There are an infinite number of lines that could pass through this point, which means 1 point is not enough. There is exactly 1 line that will pass through these 2 points. However, if I do not plot a 3rd point, I have no idea of knowing if my line is correct. So by plotting the 3rd point, I get 3 points that are collinear, and it confirms, I'm even going to use slope here. I like to try and make my graphs as straight as possible. So if you don't have a straight edge, you may want to start to use slope. I hope that doesn't make any of the other teachers angry with me. All right, but you need a straight edge here for your line to be trustworthy, okay? All right, so now, I noticed in this equation that it's solved for y, which means I can pick literally any 3 numbers for x. It does not matter what I plug in. Y equals 2 times 0 minus 4. So y is negative 4 when x is 0. Y equals 2 times 1 minus 4. So that means that y is negative 2 when x is 1. Y equals 2 times 2, that's 4. 4 minus 4 is 0. And so that is my 3 points. 0, negative 4. Doesn't that kind of look like the y-intercept? All right. 1, negative 2. And now, if this line is right, the 3rd point should be collinear, should fall on the graph on the line, and it does. So we take our straight edge and we quickly, oh, that's terrible. Why is that so bad? We quickly sketch our line. Now, just attending to precision, guys, lines go on forever. So we need to make sure that we do have the arrows. I hope I'm on screen here. All right. Number 3. Aha. Number 3 is actually very similar to number 2, but it's solved for x instead of y. And so, guys, let's pick 3 numbers for y and plug in. There's no rule that says in a linear relationship you have to plug in x. If it's solved for x, let's be smart and solve for y and plug in y to get our ordered pairs. So x equals 2 minus 0. So that means that when x is 2, y is 0. X equals 2 minus 1. So that means that when y is 1, x is 1. All right, now I'm going to try something crazy here. I'm going to plot 2, 0 and 1, 1 first. Okay? Now, I hope that this doesn't make everybody mad at me, but one of the reasons I like to explore this as an option is because now the third point that I add to the drawing should lie on the line. Okay? And so this is like saying I'm going to use the third pair as an intentional check. Okay? And so if we plug in x equals 2 minus 2, we do get 0 for x when y is 2. 0, 2 does appear to lie on the line, even though my line isn't very well drawn. And so we feel good to go. All right. We had an example similar to this in class. Guys, if y equals -3, then x and y are not related. Okay, x and y are not related. When I see this equation, what I say in my head is this: y can only be -3. Okay, when I read the equation y equals -3, the words that I say are y can only be -3. So I go down to 1, 2, -3. So now, if it doesn't matter what x is, and y can only be -3, then all I need to do is randomly select 3 x coordinates. Because it doesn't matter what x is, y is always equal to -3. So I can go ahead and do 0, 1, 2, guys, but it really doesn't matter. 0, -3, 1, -3, 2, -3, 4, -3, 5, -3. Guys, y equals is a horizontal line. Okay? Y equals is a horizontal line. And just as a reminder, the x-axis is also the line y equals 0, which means the y-axis is the equation x equals 0. That may seem backwards to you, but it's really important to understand what this means. If y can only be -3, that means I cannot go up and I cannot go down. So the only thing that I can do when y is -3 is move from left to right, and that's why there's a horizontal line. All right? If the x-intercept is 2, that is the place on the x-axis, which means y is equal to 0. If the y-intercept is 4, that's the place on the y-axis. That means x is equal to 0. So if we go to 2, 0 and 0, 4, we should be able to plot our points because we have 2 points. Okay? If you're given 2 points, you know they're correct. So why would we need a third point? I hope that makes sense to everybody. The reason we use a third point is CYA, to cover our butts and make sure that we didn't make any careless mistakes. If they are giving us the points, then we do not need a third point. We should be able to sketch the graph. So now if you notice, this is the other form of the x-intercept, and it's exactly what I converted it to. 3, 0, 0, -1. I am going to put my pencil on the first dot, draw through the second dot, draw back through the first dot, and I've got my line, okay? So the x and y intercepts are just specific examples of points that we can use to graph. One of the reasons that they're so nice is that the other value will always be 0, making it relatively easy to identify the ordered pair. All right. To find the x-intercept, I'm going to make y equal to 0. And to find the y-intercept, I'm going to make x equal to 0. 0 plus x equals 2. So 2 comma 0 is the x-intercept. Y plus 0 equals 2. So 0 comma 2 is the y-intercept. And again, guys, if you get really, really good at identifying the x and y intercepts when you're given the equation in this form, you only need the 2 points. You don't need the third, okay? The third point is just there for checking. Now, one thing that I would like to point out to you is this. Can't we, oh gosh, my pencil ran out of lead. I just ripped my paper in half. Things are going great here. Hashtag 2020. So now, guys, doesn't it seem obvious here that the point 1 comma 1 lies on the curve? And so if you want your third point just to be sure, does 1 plus 1 equal 2? It does. So that is our third point on the graph if we need it. All right. One of the things that makes the x and y intercepts super friendly is when you notice that the constant has as factors each of the leading coefficients. It just means you're guaranteed to get integers as your x and y intercept. So to find the x-intercept, I'm going to plug in y equals 0. And to find the y-intercept, I'm going to plug in x equals 0. X minus 3 times 0 equals -6 means that when y is 0, x is equal to -6. Plugging in 0 for x, it's 0 minus 3y equals -6, which means it's -3y equals -6. I hope some of you already know the answer through mental math. Again, if you leave enough evidence to show your mastery, you'll be fine. But I do not need every single little step to be followed, okay? If you show me that 0 minus 3y equals -6, I don't need you to then rewrite -3y equals -6. If you wanted to come up here and do your division because you already know 0 doesn't change -3y. Or if you get here and you say, oh, I know that means that y needs to be equal to 2. As long as you're not making any careless mistakes, I'm okay with you guys showing me that you have mastered this test because this is an Algebra 1 concept, all right? The x-intercept as an ordered pair, okay, is now, this is no longer in standard form, all right? However, they're asking us for the x and y intercepts, which means we plug in y equals 0 for the x and x equals 0 for the y-intercept. 0 equals 2x minus 3. We need to add 3 to both sides. So 3 is equal to 2x. So that means that x is equal to 3/2, comma 0. So 3/2 is at about 1 point, or is exactly at 1.5, and that's our spot. Y equals 2 times 0 minus 3 means that 0 comma -3 is going to be our y-intercept, and I'm going to plot it. All right, now wait a second. Rise 1, rise 2, rise 3, run 1.5. Well, if I'm scared about the half, can't I do another rise 3 and run 1.5 just to make sure I sketch it correctly? So if we go from here, 1, 2, 3, there's a half and there's 1, that looks like it follows the pattern. And now I've got 2 points on an integer corner, and I don't have to worry about the fraction being wrong. So I kind of like used rise over run to hopefully locate where the next point's going to be, all right? And if you guys notice, and I don't want to get ahead, but if you recognize that as the slope, a rise of 1, 2, 3, 4, 5, 6, and a run of 1, 2, 3, rise 6, run 3 does give me a slope of 2. But guys, you know what else is kind of cool? A rise of 1, 2, 3, and a run of 1.5. 3 divided by 1.5 is also 2. And so I use slope as my checking mechanism instead of the third point. You guys should look at this and already know the answer. 3 times 5 plus 0 equals 15. And 0 plus 5 times 3 is 15. Okay? So now I did that kind of fast because I want you guys not to be scared of being smart. If you start to pick up on patterns, that's a good thing, not a bad thing. Now, I'm going to do what we were instructed to do, but I want you guys to start looking for these types of things. 3x plus 5 times 0 is 15. So 3x is equal to 15. So x is equal to 5, comma 0 is our solution. 3 times 0 plus 5y equals 15. So 5y is equal to 15. So y is equal to 3. And I hope everyone sees that pattern going forward. 5 comma 3, 0 comma 3. If I asked you for the slope, I hope you could tell me that the slope appears to be -3 over 5. -3 because it's down, 5 to the right. Now, I wasn't asking for the exact value of slope, but I wanted to point out because here's what we got. All right, so for 1 through 10, let's come back. We're looking for increasing. As I read from left to right, the graph is going up, that's increasing. 2 is also increasing. 3 is decreasing. 4 is neither increasing nor decreasing. Y is staying the same. As x goes to the right, y goes up. That's increasing. As x goes to the right, y goes up. That's increasing. As x goes to the right, y goes down. That's decreasing. Okay? But if x keeps moving horizontally and y is not going up or down, then it is neither increasing nor decreasing. Okay? So 5 is decreasing, 6 is increasing, 7 is decreasing. Did I forget to plot number 8? Holy crap, my bad, guys. -6, 0, 1, 2, 3, 4, 5, -6, 0, and 0, 2. Sorry, guys. 8 is also increasing. And again, I don't know if you guys noticed or not, but when I was sketching, I kind of eyeballed that point because I thought rise 2, run 6. So rise 2, run, oh, should have been this point as well. So that means I got to go back and see, this is where using a third point can save your butt. Okay, that's why the third point is so important. All right. So positive slope would be 1, 2, 6, 8, and 9. Negative slopes would be 3, 5, 7, and 10. And that leaves the slope from line 4 to be 0, okay? If the slope is positive, that means that we're increasing. If the slope is negative, that means that we're decreasing. So if you have y equals mx plus b, and you say that my slope is 0, it doesn't matter what number you plug in for x. 0 times any number for x is always 0. And so that tells you that anytime you have an equation in y equals a constant, okay, just like number 4. If y is equal to a constant, then it's a horizontal slope. We're neither rising nor falling. We're neither increasing nor decreasing. We are staying the same, and that represents a slope of 0. I know I screwed up a couple of times here. I'll get better as the year goes on. Even if you're not in one of my 2 classes, guys, I love you. I'm here for you if you need me, room 284. We're going to get some Zoom sessions started for tutoring. We're going to get some before school started for tutoring. I hope everybody's excited. We will have the solutions posted. That's what this video is, as well as the answers. All right. I think that's all. I hope I did okay. I'll talk to you guys later.